Okay, good afternoon. So I guess it's already 1:16. So there are only 13, no? 13. So sige lang. I will start my discussion. Kitama na talas 2 po, no? Okay, so good afternoon everyone. Madunggan ako ninyo? Madunggan ra?
Yes, ma'am. Yes, ma'am.
Oh, sige. Okay, so I am going to discuss today quarter 4 modules 1 to 4. Okay, kung nabasa na ninyo inyong hard copy and so with the soft copy for the modules 1 to 4. Short lang siya. Ako na siyang gituyo nga gimubo lang ko na ako siya, gi-short lang na ako siya para mas dali and I want it direct to the point ang topic. Okay? Supposed to be ang basical ang gihatag lang sa ako nga time is good for 4 weeks only. But taking into considerations nga there are 14 modules, so therefore dili pod pwede na ako nga isa ka semana 5 ka modules akong gihatag sa inyo. Mura na ta anig ka marathon, no? And it really needs time. So therefore I asked the advisors nga mo extend ko og 1 week. Kaya nga mo extend ko og next week. Supposed to be na human na ta karon. But I still have to discuss modules 5, 6, and 7 for the remaining modules. Okay. Okay. O saan yung ipang atin? Okay, for a while, plus daghan pang mo join. Daghan pang nag-join. Okay. Okay, can you see the screen now for quarter 4 module 1? Makita ra? Basic calculus. This is okay. So quarter 4 week 1 module 1 this is all about illustrating an antiderivative of a function. So when you say antiderivative, previously for our quarter 3 topics, okay, ang topics ato are finding the derivatives, or the process is called the differentiation. Now for quarter 4, week 1 modules 1 to 4, and actually modules 5, 6, and 7, the last 3 modules talks about antiderivative of function. And this is the reverse process of finding the derivative. Okay? So I will now proceed to the first page. Madungog rag hapon ko, madungog lang, madungog ko.
Excuse me, ma'am.
Yes?
Ma'am, wala lagi ko yung makita sa imong screen.
Wala?
Yes, ma'am.
Yes, ma'am. Imurang kayo mo damong madunggan.
Sige, ako usog. Usban ako, ha? Sige. Ako akong usbon og share, no? Dito lang. Ano naman ni siya? Quarter. Okay. How about this one, Nana? Makita na ninyo?
Yes, ma'am.
Yes, ma'am.
Na, ma'am.
Okay. Okay, so this is the first page of quarter 4 module 1. So let me define first what is an antiderivative. Okay, from the word anti, no? So given the derivative, we're going to find what the general function whose derivative is given. So it would be now the reverse process of differentiation. So previously sa quarter 3, given ang function, you are asked to find the derivative. Karon baliktad. Given ang derivative, you are now tasked to find what is the corresponding, or what are the corresponding function whose derivative is given. Why I am saying is or are? Because pwede man nga ang isa ka derivative, daghan siyang corresponding functions. So many functions could have same, no? Pwede siya the same iyang derivative. And mag-matter na siya sa constant, no? Okay, so example 1, an antiderivative f of x equals to 12x squared plus 2x is f of x is equal to 4x cubed plus x squared. Okay. The antiderivative daw of f of x is this one. Nga naman, it's because if this is the derivative, then this is what? This is the kumbaga class mo siya original function nga ang iyang derivative is 12x squared plus 2x. But this is not unique. No, this is not unique because pwede man nga you can find another function whose derivative is 12x squared plus 2x. What if ako ning dugangan diri og 1? 4x cubed plus x squared plus 1. the derivative would still be 12x squared plus 2x, right? Okay, for example 2, an antiderivative of g of x is cosine x of g of x, which is equal to cosine x, is g of x, which is equal to sine x. Okay, so given the derivative, which is equal to cosine, so the function whose derivative is cosine x is definitely equal to sine x, no? Because g prime of x, the derivative of this, is cosine x, which is equal to g of x. Okay, so a little bit confusing at the very beginning, no? Medyo libog-libog siya. Sige lang, as we go along. Because for quarter 4, I am introducing what? The integration. This time, okay, we'll talk about the integral sign. We call this the what? The integral, no? Integral or the anti-differentiation, and we'll make use of the elongated nga s. Okay, example 2, other antiderivative of f of x, which is equal to 12x squared plus 2x. Okay, again, earlier, I have stated nga, kani nga derivative, daghani siyang pwede nga function nga ang derivative is equal to 12x squared plus 2x. Okay, take a look at this. F sub 1 of x is equal to 4x cubed plus x squared minus 1. Diba ang derivative ani class kay 12x squared plus 2x? Now, how about this one? 4x cubed plus x squared plus 1, the derivative would still be this one. So in fact, any function of the form, kung ato siyang i-general plus c, where c is the element of the real number, is an antiderivative of f of x. In other words, f of x, which is equal to 12x squared plus 2x, this is the derivative. Ang mga function nga ang equal nga derivative ani could be written of this form. So pareha lang siya first two term of differential lang siya sa c. C is a fixed number. Any value will do. Pwede negative, pwede positive, pwede rational, pwede irrational, pwede integer. Anyway, why? Nga nung pwede naman siya any number because take note, always remember the derivative of a constant is 0. So immaterial ang constant. Ang magmatter lang is what? The terms containing the variable, whose derivative will be equal to 12x squared plus 2x. So if this is the derivative, the corresponding functions whose derivative is equal to 12x squared plus 2x, ang function niya correspond ani is not unique. And in fact, there are infinitely many. And this could be written of this form. Magmatter lang siya sa C. Okay? Other antiderivative of g of x, I am referring to example 2, which is equal to cosine x, or g sub 1x, which is equal to sine x plus pi. Okay, so pi. And g sub 2 of x is equal to sine x minus 1 again. Pi and negative 1 are what? Real number. And the derivative of any real number is 0. Therefore, the general function whose derivative is equal to cosine x will be equal to g of x, or you can write that as g of x is equal to sine x plus c, where c is the element of the real number. Okay, so anti-differentiation is just the reverse process of what? Reverse process of finding the derivative. Sa una, you are tasked to find the derivative. This time, baliktad, no? To be the reverse. Given the derivative, what are the corresponding function whose derivative is given? Okay. Now, terminologies and notation. Anti-differentiation is the process of finding the antiderivative. The symbol, okay, this one. This is an elongated S, and this is the integral sign. Denotes the operation of anti-differentiation. The function f is called integrand. This one, function f. Capital F is the antiderivative, meaning to say the result of evaluating this one, that capital F of x, will be your antiderivative, or in other words, the function whose derivative is given. The symbol elongated S, or the integral sign or symbol, and d of x go hand in hand, and d of x helps us identify the variable of integration. Kung sa may meaning ani class. So, the integral, kung may kag na integral of f of x, d of x pug ka. Kung integral of f of y, it should be dy, meaning one variable lang. We call that the variable of integration. The expression f of x plus c is called the general antiderivative. So this is the general form. Kumbaga, any of this form will be equal to a given derivative because c could be any value. This is general. But if you are asked to find the particular, what do you mean by particular? Unsa gyud ang value sa c? Is it 2, 1, or 0? No? So kung may general ka na, any value will do for c, but when you say particular, dapat na ay value ang c, no? Exact value. Okay? So example number 1. F of x is equal to negative 8x cubed minus 10x plus 5. This is the derivative. So you're unsa man nga function nga ang derivative is equal to this one. Huh? So how do you know that this is an antiderivative of this expression or this polynomial? Okay, so we will go back to our concept on derivative. Kung ano yung derivative ani, kung ang derivative ani is kani, therefore f of x is the antiderivative of this one. So, I hope you still remember how to find the derivative. Okay, sige, rule ato. You multiply the exponent by the numerical coefficient. Always subtract your exponent by 1. So 4 times negative 2 is negative 8. 4 minus 1 is 3. 2 times negative 5 is negative 10. 2 minus 1 is 1. No need to write 1. Okay, so 5x, derivative of this. So ang 1 na exponent, di ba? Ang x na exponent 1. 1 times 5 is 5. Okay. 1 minus 1 is 0. X to the 0 is 1. That's why 5. Derivative of 3 is 0. Okay, so since the derivative of this is negative 8x cubed minus 10x plus 5, we can say that f of x is the antiderivative of this, no? No? Capital F of x is the antiderivative of small letter f of x. Okay, so example 2. If f of x is equal to x cubed plus x plus 1, and g of x is equal to x cubed plus 2x plus 1, actually there are three functions. And take note, look at the first two terms, parihas. Parihas, no? Ang kanila dahing f of x o h of x, lahi ang g of x. Okay, so we need to verify whether or not these functions here are antiderivative of 3x squared plus 1. Okay. How do we know nga antiderivative ni siya? If ang derivative ani niya is equal to 3x squared plus 1. Okay, what is the derivative of f of x? 3x squared plus 1. It's correct. So f of x is the antiderivative of f of x. How about g of x? Derivative of x cubed is 3x squared. Derivative of 2x is 2. So definitely, this is not equal to f of x. So g of x is not antiderivative of f of x. And lastly, for h of x, derivative of this is 3x squared plus 1. Okay, so ang technique bitaw ani class, pag-verify ni mo ani, tanaw lang, dapat pareha siya first two terms. Ang mag-differential lang is the what? The constant. Kung parehas yung first two terms, constant lang ang difference niya, definitely, pareha gina siya ang derivative because the derivative of constant is 0. Okay. Now, for activity, okay. So for this module 1, very short lang kaayo. I made it very simple para mas dali because I know for sure nga brag nabuyong na mong inansa sa pagkadagandag hanap yung mga deepen, napuno na akong room ug mga boxes, ang one o pag-abot, no? So kani wala na ni boxes. This is purely computation. For activity 1, okay, determine the antiderivative of the following function. So antiderivative man, so this is the what? This is the derivative. You need to find the corresponding function whose derivative is given. Okay, for number 2, this is matching type. All you have to do is to match column A with column B. Pangutana. Ma'am, i-show pang solusyon. I-show pang solusyon, ani, no need na. Take note of that. Kailangan ni mangutana na ako balik-balik, ha? Okay, activity 1, number 2, column A and column B. You just write write the letter of your choice sa corresponding number. Diretso na siya. Okay, I'm done with module number 1. Questions? Pangutana o sayo na kayo module 1, humanata. Questions?
Ma'am.
O, di ba sayo, Ra? Sayo na kayo module 1. Okay, now, I'm going to proceed to module 2. Okay. Good afternoon, Heredia.
Good afternoon, ma'am.
Good afternoon, ma'am.
Good afternoon. Let me share to you what kadyan lang. Kasi share ang ano naman eh siya. Okay. 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 So quarter 4, week 2, module 2. Computing the general antiderivative of polynomial, radical, exponential, and trigonometric functions. Okay. Okay, so antiderivative of algebraic functions. So there are guiding theorems on antidifferentiation. So first, okay, by the way, class, how do you read this one? No? Integral of dx, no? Integral. Pag elongated gani ang pagbasa na is the integral. The integral of dx will just be equal to x plus c. Why? Ganun equal to x plus c man. Unsay derivative, di ba? Integral of dx, understood nga na i1 dire. Na i1 diha supposed to be. No, na i1 diha. Okay, what is the integral? Unsa kano nga function? What is that function whose derivative is equal to 1? So definitely that would be a variable x plus a constant because the derivative of constant is 0. So theorem 2.1, the integral of dx is equal to x plus c. Now, for any real number, as long as n is not equal to 1, okay, so the integral of x to the n dx would just be equal to x raised to the power of n plus 1 all over n plus 1 plus c. Okay, so unsaon day pag-integrate? The term there is integrate. How are we going to solve if this is the case? Take note, n is any real number not equal to 1. If you have this notation, integral of x to the n dx, this is just equal to, okay, the variable, you just add the exponent by 1. All over, your denominator will be the sum of the exponent plus your c. Okay, always na kay c because this is the general antidifferentiation. Okay, sa derivative mag-minus kag 1. Sa difference sa integral, you always add 1 to the exponent. No? Add 1 to the exponent. Okay, so number 3, if a is any constant and f is a function, then the integral of a times f of x dx will just be equal to a times the integral of f of x dx. Okay, so this is familiar, no? Just like differentiation, this is what we call the constant multiple, no? Constant multiples here. So you just extract a out of the integral sign, then you have to integrate f of x dx. Then for number 4, if f and g are functions defined on the same interval, okay, so the integral of the sum will just be equal to the sum of the integrals. You just what? Imura na siyang kumbaga, i-integrate one by one, no? If there are two functions, you're going to the integral of the sum will just be equal to the sum of the integrals, or the integral of the difference is equal to the difference of the integral. Okay? Now, for example 1, okay, here, the integral of dx. Okay, so integral of dx. So what particular theorem is applicable for this case? I think this is what? 3, no? 1 and 3. So 1 and 3, so integral of 3 dx. So ato lang ipagawas ang 3, we have the integral of dx. The integral of dx will just be equal to x, no? Yeah, times 3 pa man siya, plus your c. Okay, about so, this is what? Using theorem number 2, no? So integral of x to the 6. Okay, 6. N is equal to 6, not equal to 1. So we can apply theorem number 2.2. So the integral of x to the 6 dx, kasi buhaton pag mag-integrate, you just add 1 to the exponent of your variable, and the denominator will also be the same with the exponent of your variable. So 6 plus 1 over 6 plus 1 plus your c. So this is equal to x to the 7 over 7. Okay, now how about example 3? Example 3, so 1 over x to the 6 dx. Okay, we will apply law of exponent here. So take note, integral of 1 over x to the 6 dx could be written into the integral of x to the negative 6 dx. Law of exponent. I hope you can still recall that one. So again, we will apply theorem number 2.2. So pwede siya because n is equal to negative 6, not equal to 1. Always add 1 to the exponent, same with your what? Denominator. So x to the negative 5 all over negative 5. And we can write this as negative of 1 over 5 x to the 5. No? Law of exponent again. Then for number 4, what is the integral of 4 times the square root of u du? Take note, this is consistent. Kung u diha, dapat u po din. Hindi pwede nga u dari y. You cannot integrate that one. We call that the variable of integration. Dapat same variable. Okay, so using theorem 2.2 and 2.3, we have the integral of 4 times the square root of u du. Take note, the square root of u could be written as u to the 1/2, no? Transforming radical into exponential. Okay, so we'll extract 4 out of the integral sign. Paggawas na natin ng 4. Then this is now equal to the integral of u to the 1/2 du. Okay, so this time your n is what? N is 1/2. Therefore, we can apply theorem number what? 2. So plus 1 plus 1. So 4, okay, 1/2 plus 1 is 3 over 2. Dapat kung sa exponent sa inyong variable mo, kay mo denominator. So 4u to the 3/2 all over 3 over 2 plus c. Okay, nga nang na 8 mo na siya, ma'am. Okay, 4, ang sa reciprocal sa 3 over 2. But 2/3. Okay, 4 times 2/3. So 4 times 2 is 8 over 3. U to the 3/2 plus c. Okay, for number 5, we will apply the what? The sum of the integrals, no? The sum of the integrals. So we are going to apply theorem 2.2, 2.3, and 2.4. The integral of the quantity of 12x squared plus 2x dx will just be equal to 12, the integral of x squared dx. plus 2, the integral of x dx. Okay, apply theorem 2. So 12, what is the integral of x squared dx? So plus 1 lang. So x cubed over 3. How about this one? X, di ba 1 na? 1 plus 1. X squared over 2 plus c. So 12 divided by 3 is 4. X cubed. 2 divided by 2 is 1. X squared plus c. Okay. Now for number 5. Okay, so before we can apply the difference of the integrals, so we are going to what? To apply distributive property here. So ato sana siyang i-distribute, but we will transform first the radicals into exponential. Okay, so 2t times 2t is 2t squared. This is 3, di ba? T to the 1/2, di ba? So this is t to the 1/2. 3t to the 1/2. Condition, no? T to the 1/2 dt. So, okay, so 2 times the integral of t squared dt minus 3 t to the 1/2 dt, which is equal to, okay, what? 2 plus 1 is 3 over 3. Then we have 1/2 plus 1 is 3 over 2. And finally, this is now the answer. Kulang ba ni siya og c, no? Na siya plus c supposed to be. Okay. For number 7, the integral of x squared plus 1 over x squared. Okay, so gi-apply lang diri class ang algebraic technique, no? So since we only have one denominator, pwede nato siya split atong expression, no? I-split lang, no? X squared over x squared plus 1 over x squared. The LCD here is x squared. Kung ato ni siyang i-rewrite as 1, balik ta diri sa atong original nga notation, no? Or expression. So x squared over x squared plus the integral of x to the negative 2. We'll apply the law of exponent here. So x squared over x squared is 1. X to the negative 2 is dx. So what is the integral of dx is x. Okay, what is the integral of x to the negative 2 plus 1? So x to the negative 1 over negative 1 plus c. So this is equal to x minus 1 over x plus c. Okay, now, so inyuhan ni siyang task, no? Evaluate the following integrals. This is activity number 1. Activity number 1, no? So here, this is finding the antiderivative for radicals, polynomials, and algebraic expression, no? Algebraic expression. Now, we will proceed to exponential and logarithmic. By the way, pangutana sa first part sa algebraic, polynomial, o radicals. Any questions for the first part of the discussion before I will proceed to antiderivative of exponential and logarithmic? Oh, wala yun lang. Okay, wala.
Wala, ma'am.
Wala, padayon ta. Okay. So, let us recall that the derivative of e to the x is just equal to e to the x. And the derivative of this one, a to the x, is equal to a to the x ln of a. And derivative of ln of x is 1 over x. What is ln, class? Kung naka-recall pa mo sa inyong GenMath, that is the natural logarithm, no? The natural log, no? Or the logarithm to the base e. Base e man siya, the base e logarithm. Well, anyway, manato, no? Pass is pass. Okay, now we'll proceed to theorem 2. So the integral of e to the x, dx will just be equal to e to the x plus c. And integral of this is equal to a to the x, okay? Mo ni siya, ganong gi-restrict ganina, class, na dili siya pwede nga n equals to negative 1. Because the integral of x to the negative 1 dx which is equal to the integral of 1 over x dx is equal to the ln of the absolute value of x plus c. This is the natural logarithm of the absolute value of x plus c. Okay, so special case na siya when x is equal to -1. Okay, do not memorize. It will not make sense. Okay, example 1. Find the integrals of the following function. Okay, so we'll apply the what? The sum of the integrals is equal, the integral of the sum is equal to the sum of the integrals. Okay, ato lang split ang expression. Okay, i-apply natin ang theorem 1. And there is theorem 2. Okay, the answer is e to the x plus 2 to the x all over ln of 2 plus c. Then for number 2, ang i-apply ani is theorem, this one, theorem 2. So your a is 3. So 3 to the x all over ln of 3 plus c. And for number 3, okay, ang i-apply ani is what? The law of the exponent. The integral of 3 to the x plus 1 dx, this could be written as 3 to the x times 3 to the 1. Diba? Same base, what are we going to do with the exponent? We're going to add. So this expression will just be equal to this one. And we know for the fact that 3 to the 1 is just simply equal to 3. So we will just extract 3 out of the integral sign. So 3 times the integral of 3 to the x dx, and the integral of this is just equal to 3 to the x over all over ln of 3 plus c. You may ask, ma'am, pwede na ako ni siya i-multiply ng 3 o 3 to the x? Pwede? Pwede. Because the exponent of this is 1. So you will end up with 3 to the x plus 1. Well, anyway, pwede raman gihapon nga kaniyang answer. Okay. So number 4, the integral of 2 over x dx. So this is equal to 2 times the integral of 1 over x dx. But take note, the integral of 1, this is equal to x to the -1, no? So x to the -1 ni siya. So atong ma-apply ng theorem 3, no? Theorem 3. So 2 times the integral of x to the -1, which is equal to the ln of the absolute value of c plus absolute value of x plus c. Okay, now for activity 2, inyuhan na siya, no? Activity 2. Okay. Na po, trigonometric functions. Integral of that, okay, basahan na ninyo, ay nag-memorize sa. Okay. So determine the antiderivative of the following. Okay, so we'll apply the integral, no? The integral of difference will be equal to the difference of the integral. Okay. The integral of the quantity cosine x minus sine x dx. So, gi-split na tong expressions, no? So, integral of cosine x dx minus the integral of sine x dx. The integral of cosine is sine. And the integral of sine is negative cosine. So, sine x minus negative cosine x. So, negative times negative is positive. Okay? Okay, number 2. You may wonder, ma'am, nganong naingon-ani ni siya nga wala may integral sa cotangent? Okay, so, cotangent squared, gi-rewrite na to ang equivalent expression niya based on the Pythagorean identities. This is pre-calculus, no? If you can still recall, cotangent squared x is equal to cosecant squared x minus 1. Now, we can now evaluate this one because we can apply the difference of the integrals. So this is equal to the integral of cosine squared x dx minus the integral of 1 dx. And the integral of cosecant squared is negative cotangent, wala ni squared class, ha. Kindly erase this one. Wala no? Sayop na. No, sayop na. This one, oh, kaning exponent, wala na siya. Exponent supposed to be. Delete na siya. Wala na siya ikuan. Wala na. Kindly erase that one. Okay, then minus x plus c. Okay? So, gi-apply lang diha ang Pythagorean identities. I think there are 8, no? Fundamental identities. Now, for number 4, okay, gi-rewrite lang ang expression in such a way that we are going, have factored out the denominator. So sine x over cosine squared x. So this is equal to sine x over cosine x times 1 over cosine. Cosine times cosine is cosine squared. 1 times sine is sine. And sine over cosine is tangent. And 1 over cosine is secant. And the integral of this is simply secant x plus c. Okay, how about number 4? Now for number 4, okay, so gi-apply din here again. This is pre-calculus. This is the what? The sum of the angles. So cosine of x plus pi over 3. Okay, kung cosine gani is cos, ingat pala ko si Jante, cosine sine. Pero minus ni diri, no? Okay, cosine of x, cosine pi over 3, minus sine x, sine pi over 3. So this is now the identity. This is the sum of the general, this is the addition formula for the angles. So if you have cosine x plus pi over 3, this is the equivalent expression. Kani, may equivalent expression. And cosine pi over 3 is 1/2. Sine pi over 3 is square root of 3 over 2. Okay, since this is constant, we can extract this out of the integral sign. So ipagawas natin 1/2. And so with square root of 3 over 2. And we will integrate. The integral of cosine is sine. Integral of sine is negative cosine. So 1/2 sine x minus square root of 3 over 2. Negative times negative is positive. Okay, so we are done with the trigonometric function. So activity 3, gamay ra na akong gibutang diya, tulo lang. Tulo lang akong ipa-answer ana. No? Tulo lang pero taas kinig-ansiran ma'am. Okay. No. Okay, so for number 3, kaning sign, this is difference. Okay, you are going to apply the general formula for the difference of the sign, no? Sa angles. I think sine x minus pi over 6. This is sine x cosine pi over 3, di ba? Kung sine is sine cos, sine cos. Okay, kindly review. I-apply diri ang addition formula for two angles, no? Two angles. Then this one, you apply the Pythagorean. And so with number 1, no? Pythagorean identities. You're going to transform that one such that ma-apply ninyo ang integrals for trigonometric functions. Okay, kani magamit ni diri. You need to transform the expressions para ma-integrate. Okay, questions for module 2? Wala na pangutana. Silang tag-marathon ani. Okay. Questions?
Wala.
Wala na lang. Okay, so I will now proceed to the last, no? Pasa, oy. The last modules 3 and 4. Okay. Actually, masabtan naman di agad siya class. Kung balik-balikon lang siya kuan. Okay, now module 3 and 4 talks about substitution rule, no? Substitution rule. Wait lang kay. Okay, so I'm going to share modules 3 and 4, the last module. Wait lang, di na ako ma-share, ha? Okay, 3 and 4 siya. Hindi man ako ma-share. Okay, can you see the screen for quarter 4, weeks 3 to 4? Makita ra? Hello?
Yes, ma'am. Makita ra.
Yes, ma'am.
Okay. Okay. So, okay, so these are the objectives, no? Compute the antiderivative of function using substitution rule. Compute the antiderivative of function using table of integrals. Actually, kani bitaw siya class, this is the reverse process of the chain rule, no? The chain rule. Okay, integrate that. Okay. We call this the integration by substitution. Okay, now look at example number 1. What is the integral of the quantity of x plus 4 raised to the power of 5 dx? Pwede man siya ma-integrate kung ato ni expand, pero taas kayo. Okay, good. If this is only 5, what if this is 200? This is 500, no? Taas kayo. Now, comes in the idea of substitution to make this what? The point here is to change the integrand into a much simpler nga variable. And usually, the variable being used is the letter u. Okay. Unsa na to pagkabalo, ma'am? Unsa may among i-left u diri, ma'am? Those what terms, no? Enclosed in a parenthesis, usually raised to a power, or the most complicated terms, no? Or the expression, usually the one that being what? Atong i-substitute, no? Atong siyang i-replace by a variable. Okay, so for this case, we will let u to be equal to x plus 4. That is our base. Now, since u is equal to x plus 4, it follows that, okay, ahagi ka ng du over dx. So derivative of u is du. Derivative of x is 1, dx. So here, du equals dx. So du over dx will just be equal to 1. And so du equals dx. Now, since u is equal to x plus 4, sorry. Okay, so this expression now could be written into the integral. No? The integral of the quantity x plus 4 raised to the power 5 is equal to u to the 5 du. Okay, we will i-apply na to diri ang theorem 2.2. Since n is 5, so you just add your exponent by 1, same with your denominator. Kung unsa exponent, mo pa denominator. Okay, so u to the 6 plus, all over 6 plus c. And go back to the what? To your assumption that u is equal to x plus 4, ilisan mo ng u og x plus 4 to the 6, all over 6 plus c. So this is now the integral for that particular expression. No? Okay, how about example 2? Okay, ma'am, asa may akong ilet og u ani? Okay, again, usually, ang imong gilet og u is the one being raised to a what? An exponent whose exponent is big enough. And tanaw ni mo diri, ang mas complicated nga term is x to the 5 plus 2, no? Okay, so let u equals x to the 5 plus 2. What is the derivative of u? It's du. What is the derivative of x to the 5? 5x to the 4 dx. Okay. Then, again, i-list nato siya. We will replace your variable x with your representation. So, since we let this to be our u, so this is u to d9 du. Okay, ang 5x to the 4 dx, du man na. So, integral of u to the 10, wala na ni integral class. Kuha na ning integral. Wala ni siya integral. Kigi-integrate naman wala na integral sign. Kana wala Kani wala na ni. Wala na. Kaya ni-erase that one. So, the integral of u to the 9d will just be u to the 10 over 10 plus c. Then, ilisan ang u of x to the 5 plus 2. This is now the final answer. May nana na kasayon. Okay, how about this one? Ma'am, may akong ilet og u ani. Is it z squared or the 1? Okay. Again, you use the expressions which is more complicated. Okay, so u is 1 plus z cubed. So derivative of u is du. Derivative of this is 3z squared dz. So du over dz is 3z squared because derivative of 1 is 0. So writing this one, atong i-rewrite. So hindi siya. So the integral of z squared over the square root of 1 plus z squared dz is equal to 1. Okay, nga naman ni siya. Ito lang nang gibutang diha ang z squared dz. For us to what? To group the, ato lang emphasize ang z squared dz because from here, du is 3z squared dz. So z squared dz is du over 3 or 1/3 du. So this expression is equal to 1 over the square root of 1 plus z cubed z squared dz. And 1 over this one is 1 over square root of u, kay u man eh. Then ang z squared dz is just equal to 1/3 du. No, 1/3 du. Okay, atong ipagawas ang 1/3, this becomes u to the negative 1/2. Okay, nga ng negative 1/2 man kay 1 over u to the 1/2 man na, law of exponent. So u to the negative 1/2. Okay? So u to the negative 1/2. Okay, kung i-integrate nato na plus 1, negative 1/2 plus 1, di ba? 1/2. Then, kung sa inyong exponent sa variable mo, kaya ito denominator. So, what is the reciprocal of 1/2? It's 2. That's why you have 2/3 u to the 1/2 plus c. Again, do not forget to go back to your representation wherein u is equal to 1 plus z cubed. So 2/3, ilisan ang u of 1 plus z cubed. The exponent is 1/2 plus c. Okay, then for example 4. Okay, so again, we let u to be x squared minus 1. So du is 2x dx. Okay, so I think makuha niyo yung answer. And that is, this is the quantity of x squared minus 1 raised to the power of 1/2 plus your c. Okay, ang number 5, this is what? An example of exponential, no? The integral of the exponential. So what is the integral of e to the 3x dx? Okay, ang ato i-let u ani is d what? 3x. So du is 3 dx. So dx is d over 3. Okay, so the integral of e to the 3x dx is e to the u. Kay u is 3x. Di ang dx kay d over 3 man. So paggawas na itong 1/3 and the integral of this, apply na itong integral sa exponential. Integral of e to the u du just be equal to e to the u. Okay, so ilisan na natin ang u of 3x. So that would be it. Then we have example 6. Okay. Same. Now our base lang din is what? Ang atong base lang din is a what? Constant, which is 2. Okay, so let u to be 4x. So 2 raised to the power of u. Your dx is d over 4. So d over 4. Pagawas na itong 1/4, 2 to the u du. But this is equal to 2 to the u ln of 2, no? Or 1 over 4 ln of 2. Don't forget that u is 4x. And finally, for number 7 and 8, no? Okay, let u lang gihapon. And here, the integral of 1 to the u, 1 over u is ln. For number 8, okay, atong u is 4x plus 3. Du is 4 dx. Okay, so integrating the integral of cosine is sine. U replaced by 4x plus 3. Okay. So, okay, this is now the continuation, no? Continuation sa, nakita ninyo dito nga sine, cosine na to o what? Sine na to cosine. So, these are the remaining, no? Trigonometric functions, antiderivative. Okay. So, and this is very useful when integrating expressions involving trigonometric functions. So, integral of x to the 4, second x to the 5 dx. So, your u is x to the 5. Ang derivative ani, 5x to the 4 dx. Okay, kana siya. Ato na siyang i-rewrite para makita gid nato. Thus, x to the 4 dx is d over 5. So integral of x to the 4, secant x to the 5. So this is integral of secant u. Okay, ang x to the 4 dx is what? D over 5. Again, same process. We will extract the constant out of the integral sign. Okay, so 1/5 integral of secant u du. Okay, and integral of secant u is secant u tangent plus c. And again, replace your u with x to d 5. Here, our u is x over 4. So du is 1/4 dx. Then substituting that one, okay? So integral of 4 plus cosine u, sine u 4 du. Okay, then gisplit class, gisplit ang expression. Aha, gikan ang cosecant, ang 4 times 1 over sine. 1 over sine is secant. And cosine over sine is cot. So applying the sum of the integrals is equal to the integral of the sum is equal to the sum of the integrals. Then the integral of cotangent is ln, cotangent of secant is ln this one. Okay. Okay, napajud, no? Sana naman ni ma'am. Inverse trigonometric functions. So these are their general formula. Again, do not memorize. It will not make sense. Okay, so after the class ang sa math manggod, nalang kay gihatag nga rules. The theorems, the rules, and the lemmas is very important for you to solve. So high ang notation is very difficult. So na pag-answer, no? Pero naaman na a rule which states that if this is the case, then apply this particular rule which make it easier for you to find a solution. Okay, kung bisudan barang exponent ng lupad naman na siya o kaning anong naman ni negative, it's just the notation that makes it difficult. But when you are going to know kung kabalo lang ka unsa ang particular nga rule or rules nga applicable for that particular problem, you will find it easier na dayon. And always remember, do not memorize the rules, no? Familiarize. Kaya kung yung memorize nyo, kakasabot yung sa siya. And take note, it takes a time just to come up with this particular expression. Yun sa kaninila pag-derive, no? Sa yung estudyante, mani nagpahirap na mo mga libog yun sa hindi ni makaon. Well, anyway, maybe perhaps you can say that this is beyond. But usahay mi, do not talk to strangers nga who will na dili makarelate sa imuhang topic. Min kag may sign inverse balog ay ikaw mag story ana ma'am ikaw mura na kag sa kadiha ikaw yaw-yaw ikaw kasabot. But if you're talking about when you talk about or you are talking to people who also know your topic, you magkasinabot ra, no? Kung ang math nga teacher ang engineer magkasinabot ani, pero kung ang math nga teacher magstorya ani sa wa pud kay mao ganing unsay x na malanog na unsa na si mama taka na yaw-yaw din ha. Okay, okay, so we'll proceed to examples, no? Evaluate each of the following. Sila nag-evaluate, ma'am. Integrals. The integral of 1 over 9 minus x squared. Hala, wala may ma-apply diya sa babaw, ma'am. Kaya usahay ang estudyante ito na sunsuon may abin bintot-bintot mo may ma-apply ani. But take note, ang pinakaduol diri is what? Number 1, right? Number 1, ang pinakaduol. Oh, this way 1. Dili, ma'am, oy. This may pinakaduol ani. It's number murag 1, murag pod. Okay, ang pinakaduol is 4. Okay, 4. And we are going to rewrite this one. So the integral of 1 over the square root of 9 minus x squared dx, this is equal to the integral of 1 over 3 squared minus x squared. 9 could be written as 3 squared. So 3 squared, this is a constant, no? A is a constant, greater than 0. So here, A is 3. Therefore, this is equal to the inverse of sine x over 3 plus c, or the sine inverse of x over 3 plus c. And finally, okay, number 2. Okay, so how may applicable ani, no? Sa atong inverse trigonometric function. So 9x squared and 36. Okay, so looking at this one, the operation is addition. So definitely, the naka-idea nga, maybe perhaps the pinakadual ani is either 2 or 2 or 5. 2 or 5, no? 2 over 5. Rule, okay, theorem 2 or 5. So, but definitely, because 36 of na kay variable, so let you to take note, 9x squared is equal to what? 3x squared, no? And 36 is 6 squared. So using formula 5, the integral of dx over 9x squared plus 36 is equal to, okay, du will let u to be 3x, du is 3dx. So 3dx. So dx therefore is du over 3. No, du over 3. Kaning 9x squared is u squared plus 36, no? Actually, kani siya is 6 man siya. So 1/3. Okay. Ma'am, ahagi ka ng 1 over 6. 1 over 6 is diri ka. Kani 5. Diba? Unsa may squared na to? Unsa may constant nga squared? 36. Diba is 6 squared? So A is 6. That's why 1 over 6. Okay. Inverse tan, u over 6. Your u is 3x. Okay. 3 over 3 is 1/2. Okay. So that is now the final answer. Now, for example 3, lahi po ni siya class. Because looking at the rules, may ma-apply na to din ha, di ba? May ma-apply na to 1 to 5. Okay, here, the concept being applied is completing the square. Observe that completing the square and applying formula 4. So the integral of dx all over the square root of 9 plus 8x minus x squared. Ato siyang if you're going to regroup this one, 9 minus, we have x squared minus 8x. In completing the square, half of 8 is 4. 4 squared is 16, right? So 9 minus the quantity of x squared minus 8x plus 16. Since ga-add ka, mag-subtract ka 16. Okay, to retain the what? The value of your what? Radicand. So, simplifying this one, we have 9 plus 16 is 25. And x squared minus 8x plus 16, minus 16 is, minus 16 is equal to the binomial x minus 4 squared. And this is already what? Saan siya? This is formula 4. And we are going to let u to be x minus 4. So du, derivative of u is du, derivative of x is dx. And substituting the your expression u, so dx is equal to du, so integral of dx is du over, this one is equal to 25 minus x minus 4 is u, so u squared. And again, applying formula 4, sine inverse of u over 5 plus c, because your a is 5. Okay, finally, the answer is the inverse of sine x minus 4, because you let your u to be x minus 4 or over 5 plus your c. Okay, so this is the what? This is your assigned task. By the way, ako ni siyang ipapas together with the modules to be given tomorrow and Friday. Why? Because due to the color coding scheme nga, ang uban naka-retrieve og module atong Friday. Ang uban gahapon lang. Ang uban ganina pa. Ang uban gyud. So therefore, kung ipapas na ako ni sila ang Tuesday manggod, di ba TTHS. So definitely ang Thursday ipas gina nila sa next Thursday. So kung nagkuha sila Tuesday, ipas nila Thursday, 2 days ra I think dili makaya. So therefore, I decided na lang nga ang modules 1 to 4 and 6, 7, 8 should be submitted on May 27 and 28. That would be next week. No? Kay kahit pa paano nagsugod-sugod na pod mo ani. Katong na nga late lang. Okay, so you kuhaan yung time lang to answer this one. Then ang 6, 7, 8 ako na siyang gi-short, no? Ako ra siyang gimubo para at least lang dili kay mo mabugatan pag-answer sa modules 1 to 7, which is actually whole quarter quarter 4 of Basical. Okay? So, I take into consideration for those nga na katubitang na belong sa schedule sa color coding na Tuesday, Thursday, and Saturday. Okay, wala tayo Saturday. So, definitely, ang magkuhag Thursday, ulig Thursday. Ang magkuhag Friday, uli og Friday. But, again and again, your cardboard, no, kating yung mga deepened activities should be submitted tomorrow and this coming Friday. Okay, ano na. Okay, so I guess that's muna ni siya end sa akong discussion. Questions? Pangutana.
Excuse me, ma'am.
Yes?
About sa outputs, ma'am ba? Pwede
Yes.
pwede sa di ay Friday ipas, ma'am, dili tomorrow, ma'am.
Kanus aman ka makagawas? Kung kanus ka
Friday, ma'am.
makagawas, sa Friday.
Okay, ma'am. Thank you kayo, ma'am.
Ang makagawas sa Thursday, ugma magpass sa depend activities, outputs. Ang makagawas sa Friday, dito na po ninyo ipass. Pero, katong answers ninyo sa modules 1 to 4, kani akong gidiscuss karon, and the answers katong modules nga akong ihatag tomorrow, which is modules 5 to 7, ipass na niyo dungan next week, Thursday or Friday. That would be our last meeting na. These are the last two modules nga ang i-discuss sa basic calculus. Kay again and again, supposed to be, this is good only for 1 month. Grabe ng mga ni kapaspas niya i-compress pa into 1 month. Imagine na class kung face to face pa ni, this is good for one, no? This is good for 1 sem, no? 1 sem. Nyo kuhaon lang isa ka bulan. My God. 1 module is good for 1 week, supposed to be. Ang niya, 1 day rato 3 modules, bongga kayo. No? Bongga.
Dyan, ma'am.
Perting paspasa. But, makita man po ninyo kung inyong basahan, I really make, ako na yung notice nga ang quarter 4, ako'y gahimo anak nga module. Wala na ako nag-adapt sa katong modules nga gikan sa region 10 because taas kayo, no? Taas kayo ang mga activities, daghan kayo sa nga tanan. And pati naging daghana. So what I did is I make a kana bang kumbaga simplified one, direct to the point kung unsa lang ang competency mo ra kung gihimo. And per module isa ra ko ipa-answer except for module 3 and 4 murag taas-taas. Kato lang. Because pagkuman ani kalimutan naman gihapon ninyo, no? Pero I hope so you have learned something about basic calculus because the notation is very different from the rest of the other math subjects, right? May estudyante ma'am, saan po ng mga S naman ta diri ma'am? Daghan na kay mga exponent. But soon, if you are pursuing your studies in engineering, a lot of more of this, no? Daghan pa kaya ni. Tagtulo na mga ka-integrals, tulo na ka-S, tagduha, no? Okay. Any other queries and clarifications?
Ma'am, katong
Sa yes? Asa man bilaw?
ma'am, katong sa DP.
Mm.
Ma'am,
Ha?
katong sa DP na illustration, ma'am.
Nga naman, unsa gyud na illustration board? Wa gyud illustration board.
Okay naman, ma'am, pero dako ra ka. Okay na to?
Just follow the instruction kung unsa lang. Kung actually wala gid ko gakuan og illustration kay inyo, di ba? Supposed to be this is an overdue output. Okay, so kung wala mo illustration diha kay di mo kagawas kung wala gid mo natutuyok ng pangitan na hurot na sa syudad, you can utilize your old bitang folder or any cardboard nga available diha sa inyo, ha. Make it presentable naman po, ha. Na lang. Kira. Some more queries?
None,
Basta,
ma'am.
okay, basta Friday ug Thursday ang inyong output, ha?
Okay, ma'am.
Sige, okay. Okay, if wala na questions, okay, so thank you for your time and your participation. I hope you learned something. Bisag pas-pas kaayo, pero actually, kung ato siya man, sabotable naman ni tamanan, ma'am. Kaya nga, akong example diya, puro sayon. Kay supposed to be na apay lisod ana man unta gyud. Katubatang I really wanted to expose you to different problems nga what if this one, no, daghan kaing what if, pero I don't have the luxury of time, no, to explain everything. Ako na gani siyang gi-shortcut para at least kahit papano makover nato ang competencies sa basic calculus. Bisag dili ta face to face, at least na-cover nato ang whole topics. Kaya nga nag-extend ko og 1 week. Nag-extend ko 1 week. I really asked your the advisors for STEM A nga ma'am could I extend 1 more week. Kaya expected mo nga ang STEM A ug STEM B tomorrow upat ka subjects ang inyong madawat. Thursday and Friday upat. Na si statistics and probability. Pero anyway, patapos naman pud ko. Isa na gyapon yung math. Okay. So I think wala na questions. Okay, thank you. Yes. Kinsa ni si yeah, Torres. Yes.
Yes, ma'am. Ma'am,
Mm.
subject ang ipas.
Unsa di na ako madungo.
Ang basic mga subject ipas karon 27 apil ang basic reading and writing.
Ay dili ako ara na. Ako lang. Ang iyong ipas sa May 27 and 28 is only my subject basic calculus, but for practical research and reading and writing, you really have to submit that kanas aba. Parehas naman day, no? Wala man day gihapon mo kakuha, no? Parehas ra?
Yes, ma'am.
Yes,
Parehas
ma'am.
ra, no?
Yes na, ma'am.
Ay, okay, gidungan man di ay na, gidungan man di ay na. Sige, dito na niyo ipasa ko na lang. Pero mag-retrieve man gihapon mo. Kung nahuman ninyo, you can pass it tomorrow and Friday. Pero katong mga Tuesday nga nagkuha, pwede ra na ako hangyoon si Ma'am Juan Laxi nga isabay na lang po, same with my arrangement with Basical on the next week. Kay in fairness for those nga na late og kuha, definitely shorter ilang time mag-answer. Sige. Ako na lang siyang ingnon og si Sir Legaspi. Thank
So,
you.
ikaw lang yung karon ay ma'am sa Friday.
Ang katong Tuesday o katong Thursday nga group. Katong
Sige,
Thursday.
ma'am.
Pero katong gitagahan sa Friday, nahuman na po siguro mo, no? You can pass it by tomorrow. Pero wala pa, pwede na po to next week. Ako na siyang kindly remind me, ha? Kindly remind me. Thank you, Elora, for that, idea, no? Wala na ko na siya na, thank you so much.
You're welcome, ma'am.
Sige, some more? Wala na? Nalimtan na nako siya. Akong i-consider na ako ara pong subject, dungan man distribute ang, no? Ang reading, ang writing, o kakwan. Anyway, okay ra na si Ma'am Joanne mo. Consider na si Ma'am. O lang siyang ingnon. Okay, kung wala na, then that's all for today. So, if you have some questions, you can, pwede ra mo PM na ako, no? Ay lang po kayo ng gabi na kayo. Grabe, patulga po ko ninyo. Mag-PM sa alas 11, alas 10, grabe po. Tama na po alas 8, eh. Grabe mag-PM alas 11, alas 12, huy, patang tulog ito, maraming mga kuan nocturnal, no? Kasi giram gyapon ko tanaw kuan. Pwede rin yung picture ng module, ma'am, saan any idea? Pero ayaw po ko pansira, eh. I can give idea, but I will not give you the answer, of course. Okay, so goodbye, class. Thank you. And see you for our last meeting by next week. Okay, goodbye.
Thank you, ma'am.
Bye, ma'am.
Bye, ma'am.
Thank you, ma'am.
Okay.
Bye, Biel.
Bye, ma'am.
Bye, Jaime. Bye, Justin. Bye, Biel.
Oh, grabe
Bye,
gid.
Pilaw.
Eh. Oh.
Bye, si Bal.
Bye, Bal. Bye, Congressman.
Bye, Mel.
Dagat lang ang
Oh, unsa,
panangit.
unsa na lang gid kag mag face to face na pastang bibuha.
Bye, guys.
Lagi, ma'am.
Oh, gibingaw na eskwelahan ninyo. Bingaw kay eskwelahan.
Thank you, ma'am. Bye.
Okay.
Bye, Mine. Bye,
Thank
Mine.
you.
Mauman na lagi ni
Bye,
ma'am.
Action. Bye, Nico.
Oh, mahuman happy na ta June, human na ta. Ane. Grade 12 na dayon mo. Sana all mag grade 12, no?
Real quick.
Hoping pag-result so ano yung COVID.
Oh, just praying
Bye, Mine.
mahuman na ta ni para you can Bye.
Bye-bye, James. Bye, James. James, I love you, James. Bye-bye. Bye, Nico.
Hi.
Nico, bye.
Bal.
Bye, Suki.
Dagat lang ang
Bye,
panangit.
bye, Hertiliano. Bye, Med. Bye. Bye, Zero.
Bye, Mel.
Bye,
I love
mga
you.
lods. Bye, mga lods.
Bye, Ren. Bye, Ren.
Hatagan, sir.
Ama po. Hatagan, sir.
Salamat tayo mo. Wash out ko, Stock. Salamat.
Uy, nakadungog ra ba si ma'am?
Sus, kadungog bro.
Kung nakadungog si ma'am, hatagan, sir, be.